Hi everybody, welcome to another video in pre-calculus section 6.6 double angle and half angle formulas. So now we have sine, cosine, tangent of double of an angle, and the formulas it can be easily proved as long as we know the sum and the difference identities. So to prove something like this is easy. For example, sine of 2a, if we write 2a as a plus a plus a, then we have sine of a sum. For sine of a sum, we have sine, cosine, plus cosine and sine. The angles of gamma a, sine, cosine, and this also sine, cosine, so mark that too. Right, so that is sine of 2a is equal to 2 sine a cosine a. Next, cosine of 2a, there will be 3 equivalent formulas. But we start with cosine of 2a as cosine of a plus a. And cosine of a sum, cosine, cosine, minus sine, sine. That gives us cosine square minus sine square. Right, so that's the first part. The next part of the formula is easy. As mentioned before, usually when we have cosine square plus sine square, we use the Pythagorean identity. Now if we want to replace the cosine by 1 minus sine a, so from this we have two. Either we have cosine square is equal to 1 minus sine square, or sine square is equal to 1 minus cosine square. Right, now let's first substitute 1 minus sine a square in here. So cosine square here we have, if I use 1 minus sine square, then I have 1 minus 2 sine square. Now, if instead of using the cosine square as 1 minus sine square, we use 1 minus cosine square into here. Sorry, sine square is 1 minus cosine square. And minus the negative, that's a plus. So we have 2 cosine square minus 1. Right. So cosine of 2a is equal to cosine square minus sine square, 1 minus 2 sine square, or 2 cosine square minus 1. And then we have tangent of 2a. Once again, we write it's a sum. And tangent of a sum is the sum of tangent over 1 minus product of tangent. That gives us 2 tangent A minus 1 tangent square. So that's what we have. Right. Now we just applied those formula. Now sine of 2a, sine of 2 theta, obviously there's only one formula. Except for cosine, we have more than one. But for sine, there will be 2 sine theta, cosine theta. Well, we know sine theta already. Just need to find cosine. That should be easy. So we have sine theta equal to 5/6. And sine is equal to y/r. Should be draw a triangle with the acute angle theta. Sine is y, which is 5, and r is equal to 6. Now with that we can solve for x. X squared plus y squared equal to r squared. So x, we don't know, y squared and r squared. So x squared equal to 36 minus 25 is 11. So we have x equal to plus or minus square root of 11. Right. Now to determine the plus or minus, we look at this. Theta between pi with 2 to pi. Pi over 2 to pi. So that is in quadrant 2. And in quadrant 2, x is negative, right? So I have x, and so finally cosine is x over r. So negative square root of 11 over r 6. Right, and substitute back in here, we have 2 sine of theta is 5/6, and cosine of theta negative square root of 11 over 6. And 2 and 6 cancel out, 1 and 3. So on the top we have negative 5 square root of 11. At the bottom we have 18, 3 times 6. Right, so that's what we have. Right, next, cosine of 2 theta. Well, cosine of 2 theta, we can use one of those formulas. Of course, we can use any of them. But when we look back at the problem, we have sine of theta, which is given. It always goes with something that is given. It's a lot better to use something that is given than something that we calculate. Because something we calculate, if there's a decimal, we might round off or something. Or in the problem with multiple parts, if we use something that we calculate, if it is wrong, then that will affect the remaining of the problem. However, if we use something that is given, even though if we don't get the first part right, the second part does not depend on it if we just use something given, right? So that is an advantage of that on a big scheme of things. Right, so cosine of 2 theta, we know sine, so we're going to use sine, and this is 1 minus sine square. So 1 minus sine square. And then we have 5 over 6, which is sine of theta square. 1 minus 5 square is 25, 6 square 36. Common denominator, we have 36 minus 20, so that's just 11 over 36. Yeah. That's simple enough. Of course, if we don't want to use that, and we use 2 cosine square minus 1, and this is cosine, so 2 negative square root of 11 over 2, over 6, sorry, square. So we have 2 11 over 36 minus 1. Two times 11 over 36 minus 1. Sorry, there's 2 here which I forgot. Yeah. So instead that would be 50 . Yeah. So good thing we check. So 1 minus 2 times 5 over 6, so 1 minus 50 over 36, that actually should be reduced. That's fine. Okay, fraction. It's negative 7 over 18. And of course earlier we did that. And this is also negative 7 over 18. Right. Sorry about that. But that's a good thing we check, right? So, yeah, either use that formula, of course we also can use that as well. So any of them will work. Right. Now derive the formula for sine of 3 theta. So sine of 3 theta, we can write that as sine of 1 theta plus 2 theta, and sine of a sum, sine cosine plus cosine sine. Now here we have double angle. Well, double angle here we have both side. Double angle of sine of 2 theta is that easy. There's only one formula for that. Cosine here we have 3. So the double angle here, since we have sine, so ideally I want to keep everything in terms of sine of theta. So I will use the formula cosine of 2 theta as 1 minus 2 sine square of theta. So I'll use that formula for cosine of 2 theta. And sine 2 theta, here there's only one option for that. It's a double angle, 2 sine theta, cosine theta. Right, multiply this out, sine theta minus 2 sine cube plus we have cosine theta, make that cosine square. There's a 2, forget that. And then there's a sine theta. Yep, so 2 cosine square and sine theta. Right. So it's good now that we have sine cube, and we need to write the cosine square here as the sine as well. So we have cosine square plus sine square is 1. So we have cosine square is 1 minus sine square. And we substitute into that. And the cosine square have sine theta minus 2 sine cube plus 2 and 2 sine times 1, so that should be 2 sine. And then 2 sine times that minus 2 sine cube. Then combine like terms, 1 sine, 2 sine, make it 3. And then 2 sine cube, negative 2 sine cube, and another negative 2 sine cube, negative 2, that's negative 4 sine cube theta. Right. So that's what we have for sine of 3 theta. Right. The next identities, what we call here, those are power reducing. So we reduce from a sine square to a double angle, but we no longer have power on this side. So this is called power reducing identities, which will be very important in calculus 1. This is called power reducing identity. Right, of course, usually when we try to prove, we go from one more complicated sign and then go to the other side, right? So, in this case, let's prove this by starting from the more complicated side. The right-hand side. Right, now, so we're trying to prove this. Notice that we're trying to end up on the left-hand side is sine square, right? So cosine of double angle can be any of those. But I'm going to use this one because I want to end up with the sine square on the right-hand side. So once again, we're going to use that. So 1 minus cosine of 2 theta, we're going to use that because we want to have sine square on the right hand side. So this will give us sine square. One minus one minus a negative, that's a plus. I keep forgot the 2. Sorry. One and one cancel out. We have 2 sine square over 2, and the 2 cancel out. We have equal to sine square. Right? So this is called a power reducing. If we start from sine square, it's going to be 1 minus cosine of 2 theta over 2. If we have cosine square, it's going to be a plus. Right. Once again, if we want to prove it, go from the more complicated side. By the way, the proof at the end, we just say that equal to the left hand side. Right, so that is the proof. So we start from more complicated side. 1 plus cosine of 2 theta over 2. Right, now we see that we need to write cosine of 2 theta using the double angle identity. So which one do we use? Well, notice that on the left side we have cosine square. So whatever formula we use should have the cosine square in it. So it's going to be 2 cosine square minus 1. And we're going to use that. 2 cosine square minus 1. And substitute that into cosine of 2 theta. So we have 1 plus 2 cosine square minus 1 over 2. 1 and minus 1 cancel out. We have 2 cosine square over 2. The 2 cancel out. We have cosine square, which is equal to the left hand side. So once again, if we start from sine square, it's going to be minus cosine 2 theta, plus 1 minus cosine 2 theta over 2. If it's cosine square, that's going to be a plus. So like I said, we use a lot of this in calculus. Now, the tangent square, usually we don't use this as often, but we still prove the same way. Right. So the key is, actually it's very easy. Tangent square is equal to sine square over cosine square, and we just take these two, divide each other, and we have that. But if we start from more complicated side, right, the goal in mind is tangent square on the left hand side. Tangent is equal to sine over cosine. So sine square on the top, cosine square at the bottom. So on the top, we're going to use something that have sine, because tangent have sine on the top. And for tangent, we have cosine square at the bottom. So that's why we rewrite cosine of 2 theta as that. 2 cosine square minus 1. So 1 minus 1 minus negative 2 sine square 1 plus 2 cosine square minus 1. Because 1 minus 1 cancel out, we have 2 sine square on the top and 2 cosine square at the bottom. The 2 and 2 cancel out. Sine square over cosine square is tangent square, which is what we have on the left hand side. Right. We don't use this as often as the other two. So that is the power reducing. And what happens if we have the to the fourth power? Right. Derive the formula for cosine fourth cosine theta to the fourth power. Right. First of all, cosine to the fourth power we can write as cosine square and then square. And now we use the power reducing. We just have cosine square is 1 plus cosine of 2 theta over 2. Right? The power reducing, and that's, of course, we still have the square on the outside. But the cosine square is 1 plus cosine of 2 theta over 2. Right? Next, square this fraction, square the top. And square the bottom. Right, square the bottom is 4. Square the top, I just write it multiplied by itself. Right, multiply now. 1 times 1 is 1. 1 times cosine, that cosine of 2 theta. And then cosine of 2 theta. And then cosine square of 2 theta. Right, let's combine them. Cosine 2 theta, cosine 2 theta, make that 2. And then cosine square. Right. Now, of course, we have cosine square, which we still can break it out further. That's, again, power reducing as well. But before we do that, I will split 1 over 4. And then 2 cosine 2 theta over 4. 2 and 4 cancel out. I just write this. And then cosine square over 4. Right? We split it out like that. Then we have 1/4 plus 2 over 4 is 1/2. Cosine 2 theta, and then 1/4 cosine square of 2 theta. Right? Now, what we can do is we can break this down further. Also power reducing. So we have 1/4 plus 1/2 cosine of 2 theta plus 1/4. Now the power reducing cosine square is going to be 1 plus cosine of double of the angle. So power reducing from a square to no power, but the angle have to be double. Here's 2 theta. We're going to double that. Right. Now we can multiply the straight across. We have 1/4 plus 1/2 cosine 2 theta, and that's over 8. Of course, we can split this out. Actually, I just want to write like this: 8, 4 and 2 at the bottom, and then cosine of 4 theta. Right, split this out as well. So 1/4 plus 1/2 cosine of 2 theta plus 1/8 plus 1/8 cosine of 4 theta. 1/8 and 1/4, that's 3/8. And 1/2 cosine of 2 theta and 1/8 cosine of 4 theta. So that's what we have for cosine to the 4th power. So pretty much we use power reducing twice. First a power reducing from cosine square, but we still have the square. Square the fraction, square the top, square the bottom. And that's what we end up with this combined like term as the middle. So that gives us 1/2 cosine of 2 theta, and then power reducing again when we have the square. The angle will be double, so 2 theta becomes 4 theta, and then we just keep continue from there. Right. That's what we have. Right. Now, solve this equation. Sine theta times cosine theta equal to -1/4. Well, sine theta, cosine theta. Well, if we have 2 of them, that would be nice. Now, if we multiply 2 on both sides, we have 2 sine, cosine. That gives us sine of 2 theta, right? And this gives us -1/2. Right. To solve the equation for sine something equal to a number, we will have 2 theta equal to sine inverse plus 2n pi. Or we could also have the supplement, because sine will have the supplement to that, so we pi subtract sine inverse of -1/2 plus 2n pi. Alright, so we have 2 theta sine inverse of -1/2. If we use inverse, make sure it will be easier if we use the degree mode. So sine inverse of -1/2 or 0.5, -30 degrees, -pi/6 plus 2n pi. Theta equal to pi minus minus pi over 6 plus 2n pi. Right, divide by 2 on both sides, so theta equal to negative pi divided by 2 or multiply 1/2 on both sides. So that gives us pi over 12. And n pi. Pi minus, so that is the plus 7 over 6. 7 over 6 divided by 2 is 7 pi over 12. 7 over 6 divided by 2 is 7 over 12. Right. So how many values of n do we have here? So when we look at the problem, the solution is between 0 and 2 pi. So the length of the interval is equal to 2 pi. Now, when we look at the problem, we have n pi and divide by 2 on both sides, right? So we only have n pi. So n pi and n pi, because of that, the period is going to be a pi, 1 pi. Of course, we just ignore the n. When we have the solution, ignore the n. That gives us the period. Now the length is that much. The period is half of that. So the number of n. So we take the length divided by the period. 2 pi divided by pi. Two pi divided by pi is 2. So I have 2 values for n. Two is value for n. So we just choose. Now if we choose n equal to 0, then that is negative. It's not going to work, right? So choose something bigger. So negative pi over 12 plus a pi. That will be 12 over 12, so 11 pi over 12. So when n equal to 2, theta equal to negative pi over 12 plus 2 pi. That will be 24 over 12, so we have 23 pi over 12. Yeah, 2 values of n will work, and those two will work between 0 and 2 pi. Right, here we can choose n equal to 0. And then n equal to 1. That gives us 19 over 12. Yeah, 12 over 12. 12 at the bottom, 12 and 7. That gives us 19. Right, so we have those 4 solutions. Right, so the first part of the section is double angle. Now we go to half angle formulas. So half angle formula, sine of a half angle is equal to that. Of course, if we compare that with the power reducing, you will see that they are very similar. The sine square, if we take the square root on both sides, they're plus or minus. It will be 1 minus cosine of the angle. Cosine square, if we take the square root on both sides, there's plus or minus square root of 1 plus cosine of something divided by 2. So exactly that's what it comes from. So the half angle formula comes from the power reducing. So now let's just prove sine of 2 theta. I'm sorry, sine of alpha over 2. By the way, I only need to prove one of them. A over 2, sorry. Right. Now, usually when something like this, we can measure it. Just change that to theta, for example. So let theta be of A over 2. So over 1, cross multiply or multiply 2 on both sides. We have 2 theta is equal to A. Right. Now, we will write the power reducing using theta. We have sine square reducing from sine square is 1 minus cosine of 2 theta over 2. Right? Of course, if we take the square root on both sides, sine of theta equal to plus or minus square root of 1 minus cosine of 2 theta over 2. Right? Just double angle. I mean power reducing. And now take square root on both sides. We have plus or minus. And then it's easy. We did have if theta equal to A over 2. So replace A over 2 into here. And 2 theta is A. Replace that into 2 theta here. And we end up with sine of A over 2 equal to plus or minus square root of 1 minus cosine of 2 theta. 2 theta is A. And then divide by 2. So that's what we use. Of course, the same thing can be done for cosine of A over 2. Of course, power reducing and then replace the angle. So that's pretty much it. And then the tangent is equal to sine cosine. So we just take sine divided by cosine and take square root on both sides. So that's pretty much it. By the way, we revisit this at the end of the section. But for now, when we use this formula, of course, there's a plus or minus. It can only be either plus or minus. And the sign of the plus or minus will be determined based on whatever the quadrant of A over 2 is. Right, you see. Right. Now let's use those half angle formula. Use half angle formula to find the exact values of cosine of 75 degrees. Cosine of 75 degrees is, of course, is half of 75 degrees is 1/2 of 150 degrees. Right? And cosine of a half is plus or minus square root of 1 plus cosine of the whole angle divided by 2. Right. Next, 75 degrees is in quadrant 1. Therefore, everything in quadrant 1 is positive. So this is only positive. Because 75 degrees is in quadrant 1, where everything is positive. Right. So we have just positive. Square root of 1 plus, right, cosine 150 degrees is the same thing. Actually, it's going to be negative negative square of 3 over 2. Right. Now to simplify this fraction, I will multiply top and bottom by 2. So we have square root of 2 times 1 is 2. Subtract 2 and 2 cancel out, square root of 3, and then have the 4 at the bottom, right? Then we can split the square root on the top. We have 2 minus square root of 3 and square root of 4. So 2 minus square root of 3 over 2. Right, of course we can check it is in degree mode. Yes, cosine 75 degrees, and is that equal to this square root 2 minus square root of 3 over 2. Yeah, so they're the same, so it's good. Next, sine of pi over 8. Well, what is pi over 8 is half of? Well, pi over 8 is half of pi over 4, right? So I will write that sine of pi over 8 is 1/2 of pi over 4. Right, and then sine is plus or minus square root. It's just like the power reducing. This is going to be 1 minus cosine. Now since we have half angle, cosine is could be the whole angle over 2. Right. Once again, pi over 8 is in quadrant 1, and everything in quadrant 1 is positive. In the first quadrant, so it's positive. So we have square root of 1 minus cosine pi over 4, that's square root of 2 over 2, or over 2. And once again, just like this, I multiply the top by 2 and the bottom by 2. So that I can simplify the complex fraction, right? Square root 2 times 1, 2 and 2 cancel out, 2 times 2 at the bottom is 4. So we have split, we have square root of 2 minus square root of 2 at the bottom. So we split the square root on the top and square root at the bottom. So we have 2 minus square root of 2 over 2. Of course, we can check as well pi over 8. Because if we want to keep pi over 8, make sure it is in the radian mode. Sine of pi over 8. Right, so we have that. Now we have fraction square root of 2 minus square root of 2 divided by 2. Of course, those are the same, so it's good. Now, what we have now is actually is much nicer version of the half angle for tangent. So tangent of a half angle can be written as 1 minus cosine of alpha, cosine of the whole angle over sine of the whole angle. So usually to prove something like this, it would be easier if we replace the half angle by something, and everything will follow. So what I will prove now is just this. The rest will be similar. So I'm just going to prove that. So to prove this, it will be easier if we just let half angle be something. Right? Theta be alpha over 2. Multiply by 2 on both sides. 2 theta is equal to alpha. Right. So this becomes so the identity to be proven is, I can rewrite this using theta for alpha over 2. And prove this is a lot easier. Alpha is 2 theta sine of 2 theta and then this sine of 2 theta 1 plus cosine of 2 theta. Right, prove it. This is a lot easier. Now I only focus on this. The other you can just do similar thing. Right, let's try to prove that. Now to prove this, start from the more complicated side, the right hand side. And the left hand side I have tangent. So keep in mind, if we want tangent on the other side, tangent is equal to sine over cosine. So whatever we use, it would be nice if we have sine on the top and cosine at the bottom. Well, sine of 2 theta, there's only one formula. There's only one thing we can do for sine of 2 theta, which is double angle. But on the top, we have a choice. A choice so that cosine 2 theta, the double angle of cosine 2 theta, can be written in something that has sine on the top. Once again, we need tangent on the left hand side, meaning we have sine on the top, cosine at the bottom. So we need to have sine on the top. So cosine of 2 theta, if we use sine, it's going to be 1 minus 2 sine square theta. Two sine square. Right. So that's what we use, right? Because we want sine square or sine on the top, and the bottom, there's no choice for the bottom, so we just have to go with that. 1 minus 1 minus negative, that's a plus 2 sine square over 2 sine theta cosine theta. Right, 1 cancel out. We have 2 sine square, but instead of write sine square, I can write sine times sine. At the bottom is sine times cosine. Now it's nicely 2 sine cancel out, and we have a sine over cosine, which is the tangent. And that of course is equal to what we have on the left hand side. Right. So that's how we prove it. Pretty much it will be easier to rewrite the angles in this form, so of course we don't have to deal with the half angle formula. Right. Of course this will prove the same way. So in that case, half angle formula can be written like that. With that, we go back to the previous page and add those two formulas in it. So instead of this, I can say is equal to 1 minus cosine of A over sine A, or we have sine of A over 1 plus cosine of A. Yeah. So this is a lot more convenient formula for the half angle of tangent. Yeah. Once again, just add that to the formula for half angle of tangent. Right. Now, let's do a couple of examples of the half angle formula. Right. If cosine is equal to 4 over 5, 5 sine of half of an angle, given that theta is in quadrant 2. Alright. So let's start with the formula first. Sine of half of the angle equal to plus or minus square root of, just like power reducing. If it's a sine, it will subtract cosine of the whole angle over 2. Right. Now we do need to determine if this is positive or negative. Well, that's not that bad. We know theta is in quadrant 2, right? So that means theta is between, we could use degree or radian, but if it is in quadrant 2, it will be between 90 and 180 degrees, right? Let's use degrees. So that is in quadrant 2. Now, if we divide everything by 2, we have theta over 2, therefore it's between 90 degrees, less than 90, but greater than 45 degrees. Of course, if it is between 45 and 90 degrees, it's going to be between this, which is in quadrant 1. So sin theta over 2 is in quadrant 1. It's going to be positive, because in the first quadrant, every trig function have positive values. So that's what we have. So we're going to be positive. 1 minus 4/5 divided by 2. Usually we will multiply 2 on the top and bottom, but not on this one. We try to cancel the 5 here. So multiply 5 on the top and 5 at the bottom. So give us 5 times 1 is 5. 5 and 5 cancel out. 5 minus 4 over 10. So we have square root of 1 over 10. Of course, if we split square root of 1 over square root of 10, or 1 over square root of 10. Of course, if we don't want to stop there and we want to rationalize the denominator, meaning that we don't want the square root at the bottom, just multiply square root of 10 top and bottom. So that can give us square root of 10 over 10. Right. Now, so can we do that? Can we check? Cosine is 4/5. So we can say, by the way, this is radian. Okay, that's fine. Cosine inverse 4/5. That gives us theta, right? And divide by 2. So that is cosine. That is theta divided by 2. So cosine inverse gives us theta and divide by 2. So that is theta over 2. Or we take a sine of that angle. Now is that 1 over square root of 10? It is. So that's good there. Right. Yeah, on this one, everything in first quadrant. So that's all we have. This will be turned out nicely. Right. Next. So cosine of theta over 2. So we start with the formula first. Will be plus or minus square root of 1 plus cosine of the whole angle divided by 2. Right. Now determine if it is positive or negative. So in that case, we need to determine where the angle theta is in. So we have sine is negative and cosine is negative. So sine is negative and cosine is also negative. So what quadrant is that? Sine is negative, meaning the y value is negative. So quadrant 3 and 4. Cosine is negative, the x value is negative. So quadrant 2 and 3. So put them together. This must be in quadrant 3. So where x is negative and y is negative. So quadrant 3. So theta is in quadrant 3. So theta is between 180 degrees and 360 degrees. Divide everything by 2. So we have 90 degrees. Less than theta over 2. Less than in quadrant 3. So this is 270 degrees. So that's 135 degrees. Now 90 and 135. So that is in quadrant 2. Right? So theta over 2 is in quadrant 2. So we will take the minus sign because cosine of anything in quadrant 2 is negative. So theta of 2 is in quadrant 2. So we will have cosine of theta over 2 is equal to negative square root of 1 plus cosine of theta divided by 2. Right. Now there's a problem. The problem only gives us sine. We don't have cosine. So which means we have to solve for it. Sine is equal to negative 3 over 5. And the ratio for sine is y over r. So if we draw a triangle, angle theta, y is negative 3 and r is equal to 5. We can solve for x easily. So x squared equal to x squared plus negative 3 squared equal to 5 squared. So x squared is equal to 16. So x equal to plus or minus square root of 16 or plus or minus 4. However, we do know that theta is in quadrant 3, right? In quadrant 3, the x values will be negative. We're talking about angle theta here. So cosine of theta will be x over r, which will be equal to negative 4/5. Now substitute back into our problem. Negative square root of 1, subtract cosine of theta, negative 4/5. Plus cosine of theta, negative 4/5 over 2. Right. I'll multiply everything top and bottom by 5 just to get rid of this 5. So 5 times 1 is 5. Subtract 5 and 5 cancel out, and then it's 10. So we have negative square root of 1 over 10, or negative square root of 1 over square root of 10, or negative 1 over square root of 10, or if we multiply square root of 10 top and bottom, we will get negative 1 negative square root of 10 over 10. Right, now if we check with the calculator on this one, it's a bit, have to be a little bit careful here. Right, first of all, let's keep things in degree mode so it is easier to determine what quadrant we are in. Right, if we do that, sine of theta is equal to negative 3/5. So if we take inverse of sine of negative 3/5, that is not in quadrant 3 that we want. Remember, we need to have in quadrant 3. What we have is negative 36 something. But our answer, we need the answer that is this angle. Both of these have the same y values, the same sine values. So to get to these values, what we have to do is first we're going to turn the negative. We're going to turn the negative 36 into a positive 36. And then we add 180 degree to it. So we're going to turn this to positive. And then we add 180 degree to it. So that gives us theta. So that angle is theta. To 16.87 degrees. Right. Now we want cosine of half of theta. So cosine of that divided by 2. We end up with that, with this one. Now, is that the same as negative 1 over square root of 10? Yeah, so that's good. So that's what we have. Right, so of course we don't need to check with the calculator, but I'll just do it, show that when we do the inverse, make sure that it's in the right quadrant. Right, so that is a half angle formula. We use the quadrant of theta over 2 to determine if it is positive or negative. And then that formula will be similar to the power reducing formula. And then this problem, we are given sine, we don't know cosine, so we have to go ahead and solve it. Bottom line, that's all we have. So with that, I've finished section 6.6 here, and see you in another video in calculus. Thank you for watching.